So we're going to do some review OST prep on midpoint, distance, and perimeter. So this first questionnaire is on midpoint, which we did way back in September. So I'll look back at the beginning of our OMGs at our notes. So we got point A located at -1, -5. The midpoint of line segment AB is point C at 2, 3. What are the coordinates of point B? Now, for this type of question, Desmos could help. It could be beneficial if you plug these points in, kind of help you see. I like to just draw myself a picture, a general idea of what this is going to look like, and use the formula from there. So I know that I've got a line segment AB. And we're being told that A is at -1, -5. And that point C is the midpoint, meaning it's the one right in the middle, located at 2, 3. I know that I want to find out the coordinates of point B, the other endpoint. So I'm going to use the midpoint formula, where it is x1 plus x2 all over 2, comma, y1 plus y2 all over 2. So I'm putting the average of my two endpoints. But this, we're looking for one of the endpoints, and I got to put the midpoint out here in front of where it says M. So I'm going to put 2, 3 equals, and I'm going to say my x1 is this guy, and this is my y1. My x2, y2 is for point B that I'm trying to find out. So my x1 is -1 plus x2, but now I'm just going to leave it as just x because it's going to be my only x coordinate left, all over 2, comma, my y1 is -5 plus y2 all over 2. And I'm just going to leave it as y because now it's my only y variable. And now I got to set up two separate equations where I have my x value equal to this x part, and my y value equal to this y part, and solve for the x and the y of endpoint B. So I've got 2 equals -1 plus x all over 2. Now we're going to solve for x. And then for our y's, we've got 3 equals -5 plus y all over 2. Okay. So we do know that we've got some invisible 1 here that we can do some cross multiplying for. So I know that 2 times 2 is going to equal 4. And 1 times this entire top part on the right is equal to -1 plus x. It equals itself. And now it's just a simple algebra part where I am going to add 1 because it's negative. I do the opposite. And I'm going to be left with x equals, and 4 plus 1 is 5. So that means my x coordinate is 5. Now let's do our y coordinate. Same thing, this is over that invisible 1, where we can then cross multiply. I know that 3 times 2 is 6, equals 1 times the top part on the right is the same thing. Anything times 1 is itself, so -5 plus y. All right, now again, we're going to get y itself by adding 5. And 6 plus 5 is 11. So that means our y coordinate is 11. So the coordinates of our endpoint B is 5, 11. Right, the next one is a distance type where we've got some segments that we're going to talk about. So line AB has endpoints. A is at -1.5, 0, and B is at 4.5, 8. Point C is on the line segment and is located at 0, 2. What is the ratio of AC over CB? So this one, we're looking for a fraction, a ratio. What's the line segment AC, what's that length, over the length of line segment CB. So this one, I think it would be beneficial to use Desmos, where you can plug your points in and see what it looks like. You can do some graphing. You can do your distance steps. I'm going to pull up Desmos and show you that we can type in these points, -1.5, 0, and we can even put a little label and call that point A. So it's nice and neat for us right here on our graph. And we're going to do the same thing with our point B, 4.5, 8. And let's label that guy point B. And lastly, let's do point C, that point on our segment, 0, 2. We'll label that, call it C. Okay. So now when we take a look at our graph, we might need to zoom out so we can see all the points. We got A, B, and C is going to be on it. And so we're being asked, what is this length AC over this length CB? So we need to find the distance of AC and the distance of CB. Now, when you are looking at this on Desmos, you want to be very careful to your numbers down on the axes. What are the boxes counting by? So I like to zoom in so I can see exactly the point on a box. So it looks like A is got -1.5. So each little box here is counting by a 0.5. So -0.5, -1, -1.5, -2. So you just want to make sure you're counting your boxes correctly. So I am going to pull this up on the other screen. So I've got AC here. Again, you can graph this old school on graph paper. You can use Desmos. But we want to find that length AC. And when we're trying to find the length of a diagonal, we got to use our Pythagorean theorem. So we can go up and over a triangle so that we can do a squared plus b squared equals c squared to solve for AC. So again, I'm being careful. Each box looks like it's counting by 0.5. So going up, we're going up 0.5, 1, 1.5, 2. Across, we're going 0.5, 1, 1.5. So my a squared plus b squared equals c squared is 2 squared plus 1.5 squared equals c squared. So 2 squared is 4 plus 1.5 squared is, just checking in the calculator, 2.25 equals c squared. Now we're going to add this up and we're going to get a 6.25 equals c squared. And then we have to square root this because we don't want c squared, we want just c. So we're going to do the square root of 6.25. And when we do the square root of 6.25, we actually get a nice decimal of 2.5. That's only part of it because we want a ratio of AC over CB. So now we're going to find the length of CB. So again, you can plug it into Desmos like we did. You can graph it old school, but we're doing the same idea. We're going to find that length. Being careful about what the axes are counting by. So it looks like we are going up 0.5, 1, 1.5, 2, 2.5, 3, 3.5, 4, 4.5. 5.5, 6. So we're going up 6 total because each box is counting by 0.5. And then going across to the right, again, counting by 0.5 for each little box here. 0.5, 1, 1.5, 2, 2.5, 3, 3.5, 4, 4.5. So we have a squared plus b squared equals c squared. We're going to do 6 squared plus 4.5 squared equals c squared. 6 squared is 36 plus 4.5 squared is 20.25 equals c squared. Add these guys up. We get 56.25. Again, we don't want c squared, we want c, so we got to square root this. 56.25. And when you do the square root of 56.25, we get another nice number, or not a nice decimal, 7.5. So going back to the question, we're looking for a ratio, AC over CB. Well, AC was 2.5. CB is 7.5. So our answer is 2.5 over 7.5. And if you can simplify this in your calculator, you're actually going to get 1/3. 1 over 3. That's our ratio of AC over CB. All right. Next one, number 3, we are looking for the perimeter of triangle ABC. So we're going to find all 3 sides and add them up. And we have to do some Pythagorean theorem to find the lengths of these diagonals. So from A to B, it looks like we are going over 1, 2, 3, down 1, 2. Again, we are counting by ones this time on our axes. So we're reading those axes carefully. A squared plus B squared equals C squared. So 3 squared plus 2 squared equals C squared. 3 squared is 9, 2 squared is 4, 9 plus 4 is 13, and we don't want c squared, we want c, so we have to square root it. And the square root of 13, this time it is a longer decimal, it is 3 point. I'm going to do some rounding here to 4 decimal places just to be safe. I go 4 decimal places to be safe. So 3.60555. So that tells me that we're going to round this 5 up to a 6. All right, a different color now. We're going to do BC. So going from BC, we go down 1, 2, 3, 4, and left 1, 2. All right, so again, we got a squared plus b squared equals c squared. I don't need to rewrite it this time. I got it down up there, so we're going to do 4 squared plus 2 squared equals c squared. 4 squared is 16, plus 2 squared is 4. 16 plus 4 is 20. And we need to square root that. So the square root of 20 is going to be the length of that side. So we're going to do square root of 20. And we'll again get a decimal that we're going to round to 4 decimal places to be safe. 4.4721. And I'm going to take my third color and do AC. So it looks like we got 1, and going up 1, 2, 3, 4, 5, 6. So I'm going to do this over here. Again, we got a squared plus b squared equals c squared. So 1 squared plus 6 squared equals c squared. 1 squared is 1, plus 6 squared is 36. 1 plus 36 is 37. We'll square root that. Again, rounding to 4 decimal places to be safe. 6.082. I'm going to round that 7 up to an 8. But again, we are not done because we want perimeter. So we need to add up our 3 side lengths here. So we're going to add up 6.0828, 3.6056, 4.4721 to get our perimeter. So let's do that now. 3.6056, 4.4721, And it looks like we are getting a perimeter when we add all these up of 14.1605. And this is a distance, a length around a shape. So I'm going to label it in units because I do not have any label currently. No inches, no centimeters, no feet. So I'm going to leave it as units. So next one, we've got the coordinates of the triangle are given. Again, we're finding perimeter. So again, we can use Desmos. We can plug these guys into Desmos. I'm going to show you that real quick. Clear these out from our last problem we did with Desmos. So we can plug in -4, 1. We will label that guy we can and call it P. Q is at 2, 9, so 2, 9. And you can label it call it Q. And R is at 8, 1. 8, 1. If you want, you can call it R. And again, you might need to zoom out just to see everything. And we've got our triangle on Desmos. So I'm going back to the other screen because I got it right here for us. So what's nice about this one, once you graph it, we can see that we've got one side that is flat, that is straight across, that we can just go ahead and count right away. We don't need to do Pythagorean theorem to get that distance. And paying attention to our axes, it looks like we are counting by ones, which is nice for us. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 is this bottom side. Looks like the other two sides are diagonals that we need to do Pythagorean theorem for. So, 1, 2, 3, 4, 5, 6, 7, 8. Into the right, 1, 2, 3, 4, 5, 6. So a squared plus b squared equals c squared. 8 squared plus 6 squared equals c squared. 8 squared is 64 plus 6 squared is 36. That equals c squared. Add these two up. 64 plus 36 is 100. And we don't want c squared, we want c, so we need to square root this. And this is one of our perfect squares. That length is going to be 10 units. All right, so let's go to our other remaining side. Looks like we got 1, 2, 3, 4, 5, 6, 7, 8. And to the left, 1, 2, 3, 4, 5, 6. Well, if we notice the legs are the same, they're both 6 and 8, which means we're going to get the exact same answer here for that third side. Because 8 squared plus 6 squared equals c squared, we're going to do the same exact math. So now we have our three sides that we're going to add up. So 12 plus 10 plus 10. Our perimeter, when we add those up, is going to be 32. 12 plus 10 plus 10. And again, this is units as our label. So this one, they already have units for us. We are just putting in the box 32. All right, if you do on the OST put 32 units in this box when units is already out here, the computer will mark it wrong, even though you did all the work correct and you got the right answer. The computer doesn't know that 32 and 32 units here are the same thing. So don't put the units that they already tell you units out here, just 32 in the box. Okay, next one is triangle ABC an isosceles triangle? So we have to know a little bit about our isosceles triangle definition. Isosceles triangle means that we have two of the sides congruent to each other. So we need to check out if any of these sides are the same distance. Again, they're all diagonal side lengths, which means we need to do Pythagorean theorem. So from A to B, it looks like paying attention to our axes, we're counting down 1 box, 2 box, 3 box. To the right, 1 box, 2 box. 3 and 2. A squared plus B squared equals C squared. So 3 squared plus 2 squared equals C squared. So 3 squared is 9. 2 squared is 4 equals C squared. Add up 9 and 4, we get 13 equals C squared. And I'm going to square root that. All right, so we're going to type in the square root of 13. And we're going to get 3.60. 3.60555. So we're going to round it to 4 decimal places. So that tells me we're going to round it to 3.6056. All right, let's do another side. AC, we go up 1 and to the right 1, 2, 3, 4. 1 squared plus 4 squared equals C squared. 1 squared is 1. 4 squared is 16 equals C squared. 1 plus 16 is 17. And if you get to this point, you might be realizing we don't really even need to find the length of the side because we're just trying to see, is it isosceles? Is there going to be 2 sides congruent to each other? If you do the square root of 17, it's going to be much different than the square root of 13. So right away, we're not going to have 2 congruent sides of AB and AC, but who knows, maybe BC is going to be congruent. So if you want to do that math out, you can still check out the square root of 17. Looks like it is not the same as 3.6056. It's 4.1231. So let's do the last side and see, is it congruent to either of these 2 pieces? So we're going over 1, 2, up 1, 2, 3, 4. And already you might recognize that this probably won't be isosceles because the legs are not congruent to the other 2. But still, let's double check our work. I'm going to do it over here on the left-hand side. So A squared plus B squared equals C squared. So we're going to get 2 squared plus 4 squared equals C squared. 2 squared is 4. Plus 4 squared is 16 equals C squared. 4 plus 16 is 20. Again, if you square root that, it is not going to be the same as 3.6056 or 4.1231 because they don't equal the same thing here. 13, 17, and now 20. But again, if you want to check that out, square root 20, just to be safe. I'm going to do it in my calculator, square root of 20. And we're getting 4.4721. So no, we do not have an isosceles triangle because none of the sides are congruent to each other. So not isosceles. All right, last one here is another midpoint one, but this time a little bit not extra, but a little bit trickier because we got some decimals that we gotta deal with. Same idea as we did with the very first one. We got segment QR with a midpoint M at 3.5, 2. If endpoint R is at 7.5, negative 4.5, what are the coordinates of Q? So again, I'm just going to draw myself a little picture, a little visual to see what's going on here. So segment QR. In midpoint M in the middle, and the M's at 3.5, 2. 5's looking a little weird. And endpoint R is at 7.5, negative 4.5. So I'm looking for the other endpoint. So when I think about that midpoint formula again, M equals x1 plus x2 over 2, comma y1 plus y2 over 2. I already know what that midpoint is. I'm plugging in m in for that midpoint, 3.5 comma 2. I'm looking for my other endpoint. So Q is going to be my x1, x2, I'm sorry, x1, y1. Let me make this a little bit better. And R is my x2, y2. So I'm going to be plugging those in where they go. So I've got x1 I don't know. I'm going to say it's x plus x2 is that 7.5 all over 2, comma, y plus negative 4.5 all over 2. Okay, so again, I got to match up my x value with my x values, y value with my y values. Okay, so I'm going to scroll down just a touch. Okay, so 3.5 equals x plus 7.5 over 2. And then we've got 2, my y value, equals y plus negative 4.5 over 2. Yes, we know that this 3.5 is over that invisible 1, where we can cross multiply. 3.5 times 2 is 7. 1 times everything up top on the right is the same thing. Anything times 1 is itself. So x plus 7.5. Let me just extend this just a little bit more room to right. And then I'm going to subtract 7.5. I want to get x by itself, minus 7.5 from both sides. That's bad. Let's redo that. 7.5. All right, so 7 minus 7.5 is negative 0.5 equals x. Over here on the right, over that invisible 1, where we can cross multiply. So I've got 2 times 2 is a 4, equals 1 times everything up top on the right is itself. So y plus negative 4.5. This time I'm going to add 4.5 because it's a negative, so I'm going to do plus 4.5 to get y itself. And 4 plus 4.5 is 8.5. So my coordinates for that endpoint Q, put my final answer as a coordinate in coordinate form. Negative 0.5, comma 8.